What up, Matt Leach? Whoop, whoop. All right, let's do this. We're going to talk about 1.4. The learning target is I will solve problems using inequalities in angles and sides of a triangle. As you know, I'm going to move along, so whenever I say something new, feel free to pause it, write down what you need to write down, and then move on. That's the power of this. That's why I don't wait that much. I'll usually give a little call out like right now. I'm going to say, hey guys, here's your warm up. Go ahead and pause it because after a sip of coffee, I'm going to just start right away. Makes it awkward when somebody just stares at you all the time, right? But hey, that's what's fun. Okay, let's solve these. Let's just do it. I'm assuming you attempted them. I'm just going to add 5 over. Treat the inequalities, guys, like an equal sign. There's only really one circumstance where you don't, but we'll get to that. So plus 5. This becomes x is greater than or equal to 9. Boom. I'm going to add 5.6 over. Add 5.6. And I get, let's see. Okay, listen, the addition is going to work in this battle, okay? Bigger positive number, then I have a negative number. So I know my answer is going to be positive. So now, let's just go ahead and say, all right, what's 5.6 minus 4.1? It's going to be 1.5. So this is going to be 1.5 is less than or equal to x. Notice how, watch what I can do. I'm going to flip the whole thing over, and I'm going to change this to x is greater than or equal to 1.5. It's the same, right? Big N pointed at x, big N pointed at x. Boom, look at that. Okay, and right here, okay, here's the circumstance. Now, I'm going to show you 2 ways to solve this. I don't want this to be negative. I'm going to add 2x to both sides. I'm going to add 2x over here. So I'm going to go ahead and subtract 4.2. Subtract 4.2. I'm showing you why what I do later works. Are you ready for this? So I have minus 4.2. That's gone is less than, that's gone 2x. And when I divide both sides by 2, boom, I get that negative 2.1 is less than x. Or I could flip that whole thing around and just say, hey, x is greater than negative 2.1. Now, that's kind of a long way to solve this. Let me show you how I would have actually done it. But now that you saw that, you'll know that my answer is right. There's actually a rule. Notice up here how the little end was pointed at x at first, and now it's the big end. So it was an x is less than, and it became an x is greater than. Well, there is a rule, and the rule says this. If I divide or multiply by a negative, then flip the sign. So watch what happens. That crosses out. I'm left with x is greater than. Positive divided by a negative is negative. 4 divided by 2 is 2. 2 divided by 2 is 1. So negative 2.1. X is greater than negative 2.1. That's just a one-step problem. Look at what the answer was. X is greater than negative 2.1. And that's why it works. So just know that going forward, if you multiply or divide by a negative, then you flip the sign. So let's look at this one right here. I'm just going to add 0.5 plus 0.5, add a 0 there to help out. I get that. That's gone. X is greater than, let's see, that's still going to be 5. That becomes a 2 point, and then carry a 1 over here. Boom. 1.25. X is greater than 1.25. I can write that better. X is greater than 1.25. Look at that. Boosh. Let's go, Flo. Okay. All right. It's time to move on. So normally I take you guys up and I make you look at, let's try to fold that underneath, out of the way a little bit, some theorems, because we're working a lot on theorems now. I'm trying to get this out of the way. But I've already written them down for you, and I think I had nice enough handwriting that you'll be able to roll with me on this. So let's go ahead and look at this. We have a bunch of theorems for you to write down. Again, I'm going to move through these kind of quickly, assuming that you're going to pause and write down. So this one says, instead of, you notice I started to write down, for all real numbers A, B, and C, the following are true. You would have had to write this down for every one of them. We have the comparison property, which says this. If A is less than B, or A is greater than B, or A equals B. Those are the only options we have. Either two numbers are, one's bigger than the other, one's smaller than the other, or they're the same number. So with that in mind, the transitive property says if A is less than B and B is less than C, then we can conclude that A is less than C. In the same way, if A is greater than B and B is greater than C, then A is greater than C. Going to the addition property, if A is greater than B, then A plus C is greater than B plus C. In other words, if I add the same number to both sides, the A side is still bigger than the B side. In the same way, if A is less than B and I add the same number to both sides, the A side is going to be less than the B side. All right, again, pause this as needed to write down. I'm moving on up. What do we have here? The subtraction property, same as the addition property, except if I subtract the same number from both sides, then if A is greater than B, the A side will be bigger than the B side still. And if I subtract the number from both sides and A is less than B, then the A side will still be less than the B side. Okay, again, pause this. We're moving up. Don't worry about that alert. That's for people teaching. Okay, this is theorem 6.8, the exterior angle measure or inequality theorem. Here's what we know. I have an exterior angle 1. The measure of an exterior angle of a triangle is greater than, so that's a greater than, the measure of either of its corresponding remote interior angles. In other words, notice angle 1 is my exterior angle. This is both greater than the measure of angle A and greater than the measure of angle B. That's just a fact. These angles will be smaller. And the reason I know that is those two angles will add up to be this angle. So if they add up to be this angle, they have to be each smaller individually, and together they're equal to it. Okay? All right. Pause this, write it down. Well, I guess I should make it totally visible. Pause it, write it down, and then we're moving on. Let's go. Now let's work out some math with this. This is going to seem a little bit complicated, but that's why I brought with me my handy-dandy highlighters. So we have our exterior angle measure 7. And this is exterior to two different triangles. If you think about it, let's look at triangle number 1. Or as I like to refer to it, the yellow triangle. Remember, angle 7 is greater than the measure of the opposite interior angles. Or how does it say it? The corresponding remote interior angles. Remote means far away. So angle 7 is going to be the measure of what measures less than angle 7? In other words, the measure of angle 7 is greater than because this is looking for measures less than the measure of angle 7, so we're looking for the measure of angle 7. I wrote that greater than the measure of angle. That's the angle symbol. Oh my goodness, I got to get my symbols right. The measure of angle 7 is greater than what angles? Well, it's greater than angle 5, right? Right here. It's greater than angle 4. Now, let's look at another triangle that we can form right here. What if I look at this triangle? Now, we got to do a little bit of thinking here. We know that angle 7 is greater than the measure of angle 2 plus the measure of angle 4. Therefore, if it's greater than the measure of angle 4, it's also greater than the measure of angle 2. Angle 2 has less measure than angle 7. And then angle 1. Boom. Angle 1 right there. Okay? That has less measure than angle 7. Boom, right there. See how that works? So these four angles have less measure than angle 7, or measure of angle 7 is greater than these angles. Now, what angles measure greater than angle 6? In other words, what are we saying? The measure of angle 6 is less than what angles? Less than. Let's see, where's angle 6? Angle 6 is right here. Okay? So angle 6 is less than, well, it's an acute angle, and if these two add up to this angle, then it is definitely, okay, so if we look at this yellow triangle again, I know it's a little bit been drawn over, but let's look at this yellow triangle, okay? Notice an exterior angle to this triangle is angle 3 right here. So angle 3 has to be greater than angle 6. So the measure of angle 6 is less than angle 3. because this is an exterior angle, and this is a remote angle to angle 3. Also, look at angle 8 right here. Angle 8 is an exterior angle as well. In fact, it's exterior to this triangle, the big blue triangle, right? We're looking at the big blue triangle, and because angle 8 is an exterior angle, angle 8 is greater than 1 and 6, which means 6 is less than angle 8. And those are the only two angles we can say for 100% positive are less than angle 6. I know, guys, a little head wrapping. You got to kind of puzzle solve that, but it's good stuff. All right. Let's go ahead and write this down. Here's theorem 6.9. If one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Write that down, and then, so pause me now, and then I'm going to explain this picture. Ready, set, go. Okay, now I'm going to explain this picture. Here's what we're saying right here. If one side of a triangle, this yellow side, is longer than another side, this pink side, so XY is greater than the pink, then guess what? The angles opposite them, the angle opposite the bigger side is going to be bigger than the angle opposite the smaller side, which makes sense. If I'm going to open up, right, if I'm only, I wish I could have a better way. Here we go right here. See this camera? My fingers are opening up to make room for this, but if I want to make room for the whole side, I'd have to open up way larger, making a larger angle. So it makes sense that the angle opening up for the larger side is going to be bigger. Okay? And then there's a similar, we can say kind of almost a converse to this is 6.10. Again, pause, write this down. If one angle of a triangle has a greater measure than another angle, then the side opposite the angle with the greater measure is longer than the side opposite the angle with the lesser measure. So what are we saying here? Look at this smaller angle is opposite a smaller side. This larger angle is opposite a larger side. So the measure of angle J, which is right here, right, is greater than the measure of angle K. Therefore, the side opposite of J, which is KL, is going to be greater than the side opposite of angle K, which is JL. We're going to use that to great effect. Again, pause this, write it down. Let's roll. Okay. So, check this out. We have a side, it says order the angles of angle PQR from smallest to largest. You may be thinking, but there's no angles, but I can still tell you what's smallest. We have angle P, angle Q, and angle R. Now, I know we have side 8.8, 9.1, and 7.5. The largest angle, it says from smallest to largest. So let's find the smallest side. The smallest side is opposite angle Q. Angle Q is the smallest angle. The medium side is opposite of 8.8 because that's the medium side. So the opposite angle of that is angle R. So the medium angle is angle R. And the largest side is 9.1. The angle opposite of that is angle P. So this is angle P. Boom. Look at that. Super easy, right? Check this out. List the sides of triangle ABC in order from shortest to smallest. Well, first of all, we know angles of a triangle add up to 180. So let's add these up. 50 plus 63 is 113. And we're going to subtract that from 180, which is what, 67? Boom. So this is 67 degrees. And it works similar to this. Let's find the small. Does this say from shortest to longest? Smallest angle is 50. Opposite that is going to be the smallest side. So BC is the smallest angle. So BC is less than. Oh, we should probably do this as less than. BC is less than what? Or it just says list them. I don't need to do all that inequality stuff. We're just going to say BC is the smallest. What comes next? Well, the next is 63. And 63 is opposite of side AB. And then last, but certainly not least, because it's the greatest, is 67 degrees, which is opposite of side AC. Boom! That's how we use theorems to figure out problems that seem impossible. With that said, peace out.